All right, everybody. Good morning. How are y'all doing? Thank you for being here. Okay, I'm looking forward to this summer session with you all. Just so you know, there is a recording here going on that will be on YouTube if you want to go back and look at it. I don't really encourage you to go to it now because you're here. Okay, but this is Mechanics and Materials, 65291 at Rutgers, and we're glad you're here. So what we're going to do today is hopefully a model of what we will be doing throughout the semester. I'm going to talk about the logistics of the course. We're going to go through some things. We'll mute the video. We'll let it just keep going, but we're going to mute it, and then I want to kind of get to know your names a little bit. We'll have a little bit of time to interact. And then we're going to get right into allowing you to do some problem solving, okay? And we'll go through how that kind of works, all right? So to kind of start, if you saw on Canvas, and you should have gotten a notice with the syllabus, all right? And if you're online and watching this later, you can also find the syllabus for our class on this website, which you can access. And the syllabi for 2015, 16, 20, 22, last spring, and summer 2023 are there for reviewing, okay, on the website, along with previous exams and the kind of previous videos from last semester that we created, or that I created. Okay, and so you'll be able to use that material essentially constantly throughout the course. So this website will be kind of the hub. I guess I need to introduce myself. My name is Aaron Mazzeo. And if you want to talk with me in person, I'm in the old engineering building in the D wing in D103. And we can also make arrangements to converse over Zoom. There is a Zoom link in Canvas. I'm not using it right now. And I only really anticipate using it for out of this session time, I guess, meetings. Does that make sense? So we have this long period, right, from 10:25 to 12:30, and I'm committed to being here for that time. And I think with the interactive nature of the class, I hope that your questions, most of them will be resolved in person here together in this room. I will be missing one day that I know of so far, and that will be next month, this coming Monday. I'll be in a meeting, and then I'll be back on Tuesday. Okay. The YouTube website is listed here, and you can find pretty much all the material that we're going to cover in the next 5 weeks on that website. The GroupMe, I don't know if any of you have joined it yet, all right, but you are invited. I invite you to do that. That is a way to discuss the problems, to ask questions, and hopefully get a faster response from either another person in the class or from me. We used it last semester, and people were generally pretty respectful about it, and I think it was helpful for everyone. Okay, I understand if you want to create a separate GroupMe, I'm not going to stop you from doing that. Okay, but I don't think we had a separate GroupMe. We were all in the same GroupMe last semester, and it was a positive experience. And I am very open to people helping each other, us helping each other in that GroupMe. Okay, as long as it's not inappropriate, not disparaging of another person, it's a pretty open forum, okay? And so I encourage you to sign up. Some of the software we will use this semester is all free, and we'll go a little bit more into detail in as we get into the semester, or as we get into the summer. We won't be using FreeCAD today. We won't be using Prepo Max today, but you can use Colab if you like. There's maybe one or two problems that really do require the use of Colab to solve this semester. You don't have to use it, but I hope that it might be able to make your lives a little bit easier. And if you're interested in learning a little bit why you would use Colab, there is a video on the website that I created that goes over tips on how to use it. And we can go through that. How many of you are familiar with MATLAB? Okay. This is very, very, very similar to MATLAB. There are just maybe a couple things I'll point out, and maybe this is a little bit disorganized, but so if you go to our first session, which is today, okay, you'll see, and this is what I encourage you to watch as you're working on the problems. I also have other videos here on the website, okay, but we'll talk about that in a second. But if you go all the way down to the bottom, okay, what you'll see are a link to the instructional slides, the slides I'm showing you right now, that you can download in PDF and are actually more inclusive than what's in the video, but those are the slides that are in the video that I produced. And you will also see down here further, right here, this Colab and IPython Jupyter Notebook. Okay, so if you just go over and I right click and it's opening it in a new tab, which is right here. Okay, what you'll see is, something that looks a little bit weird if you haven't. Actually, how many of you have used Python before? Okay, not as many as have used MATLAB, right? Please do not be scared. Last semester, there were people that would take the Python code, bring it into MATLAB, run it in MATLAB, take a screenshot, and put it on the GroupMe for other people, okay? I hope that I can show you in 5 minutes that that's not necessary, okay? The things to keep in mind are, one, have any of you used Mathematica before? No, okay. So Colab is kind of set up well, I don't know. Somehow they have worked out all these intellectual property issues, okay? Because this is a product by Google that uses open source Python, okay? And what you have here are different cells. Like these are just text. Nothing happens here. But if you click in this cell, and you can do this right now, right? You can go to the website. I'd actually encourage you to follow along, okay? You can go right here. The first thing that a lot of people may not think they have to do, but you should do, is come here, and if you click this little play button, okay, it runs the cell. Now you notice it's probably very small. It also has this little shortcut called Control-Enter, which runs the cell. Okay, what this is doing is importing the necessary libraries to be able to run some of the functions, not all the functions, but some of the functions. Okay? And I will often go right to the cell where I'm trying to run it, and I forget I didn't run the first cell, okay? So anyway, so if you hit Control-Enter, okay, it will run, yes, okay, this. And the other thing you can do is you can copy this Colab. So this is just a template, right? But you can copy these Colab files into your own Google Drive and be able to edit them and manipulate them there, okay? So this one is run, okay? And now that allows us to run these other ones. So if I hit Control-Enter, right? And you can see it's already calculated these things, but that's the process, okay? In some cases, for this class, all you have to do is hit Control-Enter, right? I've given you the code, Okay, so, or you might just be manipulating, and this first assignment, literally down here, on this, like, what you can do is just put in the different numbers, all right, that you see there are numbers here, okay, like 4.45, well, that's a conversion, sorry. Sorry, where are the numbers? Oh yeah, the numbers are up here. I'm sorry, the numbers are up here for F total, F strut. Okay, I mean, you can just put in different numbers, okay, to manipulate things. Oh, and then there are some hidden calculations. There's symbolic stuff. There's, you can, and so the hidden code, it's just hidden because I thought it was even more excessive. It's not secretive. You can go in there and if you want and pop it out. Okay. Any questions on this? All right. So all these are accessible from the website, okay, that you see here at the top. Okay. And I update this, so you'll see that by tomorrow there'll be some new stuff up for session 2. All right. Other things here. One is this notebook is Summer 2023 in-class and office hour notes. So yes, I use Microsoft products for the PowerPoint slides, but I give you the PDFs. We use Google, right, for the Colab, and you have an opportunity to also look at any additional in-class or office hour notes that I might be doing with an individual. So if you come to me in office hours, what I'm going to try to do actually, even though we'll be in the same room, okay, in the office, is I will go ahead and say, okay, let's both log into Zoom, and instead of using a whiteboard, which I have in the office, which we often do use too, we'll actually work right here, okay, in the OneNote, and then everybody will have access to what happens there. All right. Yes.
So where did you find the page before?
Okay, so this web page, right?
Yeah.
If you go to the syllabus, right, which
it's
in Canvas,
yeah.
right, there is it's this second website listed right here.
Okay, thank you.
Okay, if you click on that, that will take you to where you want to be. Okay, and I created the website last semester, and just so you know, okay, full disclosure, there's no advertisement on the website. I'm not allowed to make money from you all as you're taking the course, right? So there should be no, if you ever see advertisements on that website, it would be when I'm not teaching the course, all right? Because I'm not allowed to have external income from this content, all right? Same thing for the YouTube, all right? That's like while I'm teaching the course, or if you're a student in the course, and I have no way of distinguishing whether or not you're in my course right now, right, or not. So there should be, YouTube will probably still put ads, but I'm not making any money on those ads, okay? These are educational, I'm being paid to teach here, right? So it's a tool that we're using, and I think it's helpful. And I hope other people that might be watching on YouTube find it helpful and want to participate in it, but that's just, I have to disclose. And I think the rule is I have to actually contribute anything that would be made from a textbook that I produce, that I prescribe to a class, according to Rutgers ethics, I have to give that money to charity, all right? So we're not gonna even go there. We're just, okay? So please don't hold anything back from using these things, these tools that we have, all right? And I try to also give credit to other people, as you'll see. There are some wonderful YouTube creators that have done an excellent job showing example problems for this course. Please feel free to watch those in this room as you're doing the problems. Feel free to share them over GroupMe. Feel free to put a comment and say, look, I think this video is really helpful. I'm interested in having the best online content that we can, all right? Now, let's get to this line, suggested textbook, all right? So what I'm gonna do this semester, all right, is attempt to map out the appropriate sections in Hibbler's textbooks, 2 of them. So I have a copy of the 9th edition, and this is the 11th edition. I don't have a copy of the 10th edition. And in the office, I have a copy of the 8th edition as well, all right? This is a great resource, okay? Last semester, we just said it was optional, and I don't think many people will use the textbook, but you can find nice examples in here to supplement what we're doing. So I won't hold you back, and I'll try to point you to the appropriate sections. Today's session doesn't really have a section, okay, in the textbook, so there's nothing to really point out there, okay? But this is one of the texts. Another text that you'll see, there are 2 other texts that you'll see references to in the notes. One is from Crandall, Dahl, and Lardner, 1999. Okay, this is the textbook that I used when I took mechanics and materials. And I like some of the things that they put out there, so I'll just have references, but please don't feel like you have to get that book. And then also the book that I've used when I've taught DMC, which is Design of Mechanical Components here at Rutgers, which is 65342. That book is by Juvenal and Marshek, and you'll see some references there to that book as well. Okay. In terms of how we're going to take care of our schedule and grading, okay? Which, of course, we all are concerned about. What I've tried to do is make it so that some of the double sessions, all right, so what you see here, there are 25 sessions, okay? So this is what we did in the spring, and if you look at prior syllabi that I've had, similar content. It's a lot to get in 5 weeks. I've never done it, and this is my first time teaching a summer course, okay? So I've never done it this accelerated. I think it's doable, okay? Note, though, the amount of work that is going to be required is quite high, right? We just do the simple math. This is a 5-week course, a little bit over a month, when we normally have a semester that is, let's say, September, October, November, December. That's 4 months, okay? So 4 months divided by 1.25, all right, that comes out to what? Something like 3 and a little bit and change. So the amount of time that you expect to spend on this course equates to 3 classes in a regular semester per day, okay? That's intense. That's intense, right? Now, what I like about this is this class will allow us to get to know each other, okay? And we're not going to have, how do I say it? Some of the same techniques for measuring performance as you would in a large class, okay? When you have 117, 120, 120 something students, it's amazing how the distributions, what you do, you plot it all out, it's Gaussian. You can ask students who have taken the class with me before. This class ends up being very Gaussian, okay, when you look at the distributions. It ends up being very hard, too, if you talk to students who have taken it before, okay? But what we're going to try to do is make sure that if everyone's participating, doing what they're supposed to be doing, I'm going to try really hard to provide the assistance and everything so that we can, as much as possible, succeed. Some things that are going to be different than what we've done in the past is we're going to require attendance, okay, with this class. And I expect that we're also going to, and I've tried this, but I think now it will work. Okay, we're going to form groups, somewhat semi-formal, okay, or formal, all right? So what I envision happening here, you can choose whether you watch the video with the content at home the night before, okay, or you watch it here with headphones or whatever you want to do. Okay, I'm fine. I encourage you to watch the content. Okay, that's the goal. I will do less talking like this probably, okay, than maybe today. We'll see how it goes, right? It depends, right? If there's a question, then what you'll see is we'll go and we'll talk about it, and it'll be recorded for the live sessions, and you can go back and see it later, right? The idea though is you're viewing the content either in class or before class, and then you're working on the problems. Okay? And the problems are probably going to take more than this class time allows, to be honest, right? We're talking the equivalent of 3 classes per day, right? At least for some people. Some people maybe not, but my experience is that last semester, not many people in just the hour and 20 minutes that we had could finish all the problems in a session, okay? So I expect it to go a little bit beyond, and then that's when you can use the group me, all right? That's when you can use your context. So a couple of things. So what we're going to do is we're going to form groups of 3 or 4 students, all right? And what I would ask, today it's just whatever, right? But what I'd ask is that you send me a message if you have any preferences. You don't have to include the other people, all right? Just send me a message if you have any preferences for who you would like to be in that group by like midnight or 1 a.m., whatever. I'll get to it tomorrow morning, okay? And then I will send out the list of the groups, okay? So if you have like a preference, like you want to work with so-and-so, or if you have a preference like, please don't put me with so-and-so, send that to me too, right? Completely anonymous, and then everyone will be assigned groups, right? Yes?
What are the groups going to be used for?
Working together to solve the problems.
Just in class? Okay.
In class, yes. Okay, that's it. Now, I still believe, based on my undergraduate experience, that one of the reasons that I was able to, that undergraduate classes were a lot more fulfilling than some of my graduate classes because I had a bunch of people and I had friends and I had people I worked with. Like, it was late nights working on problem sets together. Okay, so what we're doing is bringing that here to the classroom a little bit. Right? And what we're also adopting here is more of a flipped classroom model. Okay? Last semester, one of the reviewers wrote, I was ticked. They didn't write this essentially, but well, they kind of did. It was like, I was telling all my friends that this professor stopped teaching, right? And because last semester we transitioned to flipped, right? And that was difficult, right? But today we're going to try to start that way, so we will not have some of the pain that was involved with flipping, transitioning to flipping. But this person was saying, I was telling my friends that this professor stopped teaching, and why is he getting paid to teach? And then they're like, but somehow this weird method of having the classroom flipped essentially made it so that I was learning the material better. And I don't know how it happened, but whatever you're doing, keep doing it, essentially, right? Now you have other people who have maybe contrasting opinions. That's one data point, okay? As we work together, okay, so it's going to be one of these things where you're going to be working on the problems, you're going to be watching the videos. As you have questions, I'll be walking around and I'll be hopefully helping you or helping us to understand the material better, okay? Any questions on that format? All right. So what I expect, all right, is I will know all of you by name by the end of this first week, okay? And our class participation, so you'll be able to see the attendance, all right, because I have it set up in Canvas, and so I'll just go through and I'll, so if you want to pretend to be someone else, today's the day to do it. Not just, no. So, but no, because and we have your photos and stuff too, of course, right? So don't do that. Okay, but I'll get to know you, and so attendance will just be straight up 5%. Now, class participation, in the past, my metric was, do I know who you are, all right? And surprisingly, in a class of, when you have the trickle-down effect, not that trickle-down effect, but when you have the contraction of the class as people stop attending, right, in other classes, I pretty much get to know who's going to class, all right? And I try hard to get to know their names. So class participation pretty much was just, do I know you? And then students will come to me after the final exam and they're on the border. And I'm like, who are you? And that's it. I mean, your class participation at that point is pretty much zero because I don't even know who you are, right, when you walk into the office. Now here, I expect that won't be the case. Okay? And it's not completely zero. There were cases where it's like, yes, this student was very prolific on GroupMe, all right? Another form of class participation. And they don't need a full point, they just need a little bit. So, you know, maybe I can, well, all right? But the class participation grade is pretty much just a bump, right? And no one wants to be on that border, but it turns out that a lot of people end up being on that border, okay? Assignments, we heavily weighted, right? So the way we've got it, this is the first time where the assignments are more than any of the individual exams. Right? The way the assignments work, yes, you could probably find someone that maybe had notes from last semester, okay, and then use them. Okay, I mean, I'm not going to stop you from doing that. The way the problems are set up in Canvas, right, is that most of the problem, I'd say 90% of the problems, populate with individual numbers for individual people, right? So even though you're working in teams, you're going to be, or groups, you're going to have to be solving the problems somewhat individually, all right? Unless you just copy the final symbolic form. I'm a big fan of trying to keep things in symbolic form as long as possible and then substituting numbers in the end. When we get to Moore's circle, not always a good idea, all right? There's some things in this class where that's a bad idea, okay? But keep things in variables, and that's also kind of conducive to doing things with Colab, if you decide to use Colab, okay? The 3 exams, right, we don't have much time. In a couple of weeks, we'll have exam 1, and a couple of weeks later, we'll have exam 2, and then on the 6th of July, we'll have the exam, the final exam, okay? And I will not be here, like I mentioned previously. I will be missing session 5 on June 5th, but you're welcome to meet here. So that will be one day where I don't take class attendance, obviously. But I'll still, hopefully, I'll be in California for one day. It's going to be so painful for this meeting. For 1.5 days, whatever it is. So, I'll still be available on GroupMe and stuff during that time. Okay. Any questions? Any questions? All right. We've already kind of gone through this. So if you haven't joined the GroupMe, please do so and feel free to change your name for anonymity. All right. That's perfectly fine. You can do that. Yeah, okay, so there will be some blank, okay, but they're typically not. They're typically just complete at this point, okay? So, if you really want blank notes, okay, let me know. But I think there are enough tools with PDF editors out there now that you can just add a page in between to take notes as you're viewing content. Okay. Okay. Assignments. So they're already all available on Canvas. Okay. And I think I got the dates right. Okay. Typically, what will happen is they will be due. If it's like, so today's assignment will be due by 10:30. So we start at 10:25, whatever, but it essentially is due by the beginning of the next class. And that goes. And then and then there's some days, the days right before the exams, what will happen is the session that we cover the day before the exam will not be on the exam, okay? But the material that's due the day before the exam will be on the exam. All right, so just to go through that quickly, before exam 1, and you can go back, this is all recorded, right? So before exam 1, you would be responsible through session 10, okay, right here. So indeterminate twisted rods. This assignment will be due on the Monday. So right, this is a Thursday, 6/8, is due on the Monday, and then the exam is on Tuesday. The content that we cover on the Monday, that will not be due until the Thursday, so we'll leapfrog. Okay. Similarly, for exam 2, we will get through absolute max shear stress. Okay, this content will be, this is not as forgiving, right? So the exam here is on a Wednesday, so this will be due on a Tuesday, and then we will not have session 21 on exam 2, but that will be and this assignment will be due on the Thursday after the exam. Yes.
I just have one question.
Yep.
On my schedule, it says classes from 10:30 to 12:25.
Oh, is it? Did I get it wrong?
It doesn't matter 'cause it's fine.
No. Okay. Good. All right. So I got my co-fit or my last. That's fine. Okay. So we will. Yeah, we'll start at 10:30 then.
Okay.
That's fine.
I'll be here 5 minutes early.
No. That was not me. That was me being. I got my. Okay, so we go 10:30 to 12:25.
That's what it says here.
All right, great. Then we will stick by that. We started a few minutes early. Thank you for. I'm sorry for those of you who walked in at 12:30 or at 10:30 then. Okay. So we'll take care of that. Okay. All right. So what I'm going to do is I'm going to mute the audio, and we're just going to get to know each other for a few minutes. Okay. Let's see how I do this. Yeah, I just. Okay, so we're back in terms of the audio, from what I can tell. And so what I'd like you to do is to go in to Canvas. All right, and this is kind of just you're good?
Yeah.
All right, go into Canvas, and this is kind of an example of what you should see. You should be able to go into the first module and see the following. Okay, you should be able to see these 3 questions. And you'll see that they're worth 0 points. Okay, so this is just for us to have a little bit of a conversation. All right, you can see what I'm doing here. This is pretty much right now. This would be the only upgrade per se for the slides from what we had in last spring. Okay, but I've added questions to the slides in that presentation to kind of tell you where you would want to stop the video to be able to answer the questions. Does that make sense? So if you if you go to the website here, right, and you click on instructional slides, what you'll see, I mean, maybe it's easier sometimes if I just do this, is that this comes up, and yes, there were questions here. These are introductory questions, but like later on, what you'll find is different. Is that now I've put the question, so if you're watching the video, you know when there's an appropriate question to go ahead and answer. And in Canvas, oops, that's the wrong keyboard. All right, whoops, that is not the right website. Okay, this one, what you'll see should come up as the modules initially, and so you can go in and you should be able to just click on these. All right, and if this works, what I should be able to see when I come in here, I should be able to see your responses. So the first question is like, what are a couple materials, that shape your everyday life? Okay, so just punch in some stuff and we'll just talk about them for a few minutes. And these are not, crud, it's showing, I'm gonna have to do this not here because it's showing someone's name. So I would try to do that over here. Apologize. Yeah, there are so many questions, right? Is that what I just heard? Yeah, there are a lot of questions. Okay, let me see if I can go. Okay. Okay, so let's see. Let me. All right, so I see some there. Okay, so good. So we are getting like glass, plastic, metal. Silver, rubber. Copper, silicone. Okay, silicone. Yes, it's a form of rubber. Wait, what? Did you just appear?
Yeah.
You just appeared.
Yeah.
Okay. How did I not see you walk in?
I even say hi.
You even said hi?
Yeah.
And I just ignored you?
You
Yeah.
were adding him to your.
Oh, okay. All right, great. We'll get to know each other in a second. Thank you for joining us today. All right, so silicone, all right? Okay, so silicone is a material that will change your life, okay? If you do research, it is an amazing material in that you can just add these two components together, a base and a curing agent. Many of them are platinum base cured, okay? And it will harden over time, okay? Temperature accelerates it. So one of the ones that we use in our lab a lot is called polydimethylsiloxane, PDMS, or the traditional material is made by Dow Corning, called Silgard 184, and this material has been so useful for many people for research. One, it's very, very transparent. Okay, it has great transmission to light. Two, it's not that hard to form or to make a mold for. Okay, so things from microplumbing, microfluidics, to electronics, flexible electronics, to soft robotics, okay, have employed the silicones. Things that respond to pressure, things that respond to external stimuli, it deforms, it replicates features down to a couple of nanometers. It's a really amazing material. Okay, so silicone, it changed my life, all right, when I was a graduate student. And I focused on how to get rid of bubbles from silicone. That was my PhD thesis. And what we did is we spun the liquid before it was curing, or as it was curing, and the bubbles would travel as you spin a liquid. And we would do this and introduce, hundreds of Gs essentially to the liquid. And we did some at Rutgers as well. But when you do that, you're spinning, right, a disc, for example, that has liquid in it. And which way do the bubbles go? Well, they go against gravity, right? They don't go to the outside because it's less dense, just like soda pop, so they come to the middle. All right, so it's pretty cool. So we worked on using this form of centrifugal forming to be able to move the bubbles to the middle and get them out. They also dissolve into solution, it turns out. So you have two ways of getting them in and out of solution, either by applying vacuum to make them bigger, to get them out, and then they can expand and travel up, or by pressure where you pressurize them in. But another factor is that you can change the concentration of dissolved, okay, you guys don't care. All right, I'm going off on this. You can change the concentration of dissolved air in the PDMS by applying vacuum. So that means that as a bubble is formed and there's surface tension that causes there to be high pressure inside the bubble, it actually creates a gradient in concentration, which causes the bubbles to collapse, okay? Because it goes from high concentration in the wall of the bubble to the surrounding solution. And so the bubbles will actually get smaller just by changing the concentration. All right. Okay, yeah, copper is a good one too. Sorry. Metal, so what material, so I went off on that tangent, right? But what material are we really going to be focusing on a lot here in this class? Yes, metal. And what?
Steel.
Yeah, how did you know that?
I
Okay,
just knew.
you just knew, right? Yeah, steel is a magical material.
Yeah.
Okay? Because you can, you can heat treat it, you can plastically deform it, and these things change its strength. Okay, and it maintains the same elastic modulus. We'll have a whole thing on material properties, okay? But it's a cool material. It's a really great material. And of course, you can change its composition, okay, by changing the amount of carbon that's in it. All right, let me see. Still looking at people's responses. Yeah, iron. So of course, steel is made of iron, primarily iron. Okay. Copper. Copper is amazing because of its electrical conductivity. It's also amazing for other things too. We use it in structures. Wood. Often unappreciated by mechanical engineers, to be honest, right? How many wood shops do you see in mechanical engineering departments? If you go around? Like none, right? But we have a wood shop in the makerspace here at Rutgers. So if you ever want to do some woodworking, you can go to Livingston campus and you can do work there. Oh, okay. Food. Nice. All right. And a PS4. Okay, yeah, all right. So PS4 is we can argue is a significant composite because it's got a lot of different materials in it. Okay, now I know who you are though. Welcome to the class. All right, aluminum. Oh, I love aluminum. Who doesn't like aluminum? It forms a oxidizing layer almost instantly, and that makes it very resistant to corrosion. And it's just like butter when you're machining it. And it's like lightweight, right? What's the specific density of aluminum? Anyone? Or the density? Okay, what's the specific density of steel? Okay, what's the factor between them? Any ideas? Take a guess. If you have a hunk of aluminum and you have a hunk of steel, how much more dense is steel? Just take a shot.
4x.
4x, okay. So 16 would be a little bit much, but yes, 4x, so yes. What were you guys?
8.
8, okay, 4x is closer, right? So,
5.
no. We don't, no need to go over 4, right? So, you can fact check me on this, but iron or steel is about 7.8, all right, and aluminum is 2.7. So 7,800 kilograms per meter cubed and 2,700 kilograms per meter cubed. This person also put wood. Nice. All right. Still thinking. Yeah. Okay. Yeah. Yep. So plastic. Plastic is amazing too, of course. Right. And anyone know the difference between thermoplastics and thermoplastics and thermosets? Anyone? Okay. Anyone use the epoxy? All right. And we talked about silicone already. Okay. What's interesting about epoxies? Yeah.
It's heat resistant.
Okay. They often are heat resistant. A lot of them can be. Yeah.
They'll bond to pretty much anything.
Yeah. They can bond to a lot of different things. Yeah. Okay. These are good points. They're heavily used, and they're especially used in composites, like with carbon fiber or with glass fiber inside of them as well. But yeah, when you go to your hardware store, right, you'll see the whole section of those high strength adhesives. A lot of them are epoxies. Those are thermosets, okay? Because what happens is they go one direction. They harden when you mix the two together. What happens if you try to melt a thermoset or a thermoset? Well, it essentially chars. What's happening is you have all these spaghetti polymer chains that cross-link, so they form these bonds and they harden, and that's where it gets its elasticity, its rigidity. Okay, but the thermoplastics, they are essentially just being melted and cooled. Now there's crystallinity, there's other things that happen, right? But many of the 3D printers that you see now are using thermoplastics, right? Because they take this feedstock, they heat it up, it becomes kind of this goo, and then you can print it, and then it cools and it hardens. That's a thermoplastic, thermoset. It's one direction. It hardens, and that's it. It's irreversible. It's a problem for recycling as well, right? The thermoplastics, they can be heated and reformed. Okay, good. Good. And let's see. What are people's thoughts about why things break? This one was just verbally. Yeah, let's go ahead.
Stress and strain.
Okay, yeah, stress and strain. Okay, so you have there are two important quantities that we'll cover in depth in session 4, and they stress has units of pressure. Okay, so newtons per meter squared, or some type of force per area, and that has to do with, and we'll talk about the different forms of stress, the axial, the shear, okay? But essentially what happens is you've got all these molecules, right, that are somehow kind of sticking to each other, and when we exceed the amount of load that's necessary to keep them together, that's when they break, right? That's the short story. But the strain, right, is strain and stress go hand in hand with each other. Okay, and we'll also talk a little bit about the difference between what are material properties and what are structural properties. Okay, so if I tell you that this desk, if I sit in the middle of this desk and I sit on it with a load of 500 pounds, okay, or 500 pounds, that's the conversion between, so 1 pound is about 4.45 newtons, okay? So, 500, that's, I don't know, what is that? That's somewhere between 2,000 and 2,500 newtons, right? Something like that. So, if I tell you that that's the force that it can handle, that's a structural property, okay? That's because of the thicknesses, the materials selected, and their strengths, and it's been designed. That's this material, right? And you don't really care what the dimensions are, and it has some type of strength. It has some type of what we'll call modulus, elasticity to it, right? And that is something that's just intrinsic to the material. Now it's dependent on processing as well. It's dependent on composition, of course, but those are material properties, which usually have some type of measurement per unit area or per unit volume, okay? And so it's important to be able to distinguish between the two. The reason we care about characterizing materials is so that we can also characterize structures, right? So like the material structure is like, okay, or the structural properties are indicative of functional requirements. And you can have functional requirements for the materials as well, but material properties, right, you use those material properties to then look into building structures and predicting whether or not you're going to have failure. Good. And I think the last question is about, what do you want to learn? And maybe that's a little bit more private. But any things that you are like hoping that you want to verbally express in terms of what you want to learn this semester? Or this summer? Yes?
I got patience for like aerospace stuff and like space exploration stuff.
Okay, all right. Yeah, so that would very appropriate coming from you and Ethan. So we this class is very general, okay? But you can, one of the things that will happen in this class, and it happened more for dynamics for me when I was an undergrad, is that you look around the world and you see this table, for example, all right? And you're like, oh, wait, that's kind of like a couple of beams with a cantilevered, it looks more like a plate, but it was a cantilevered structure in between them, okay? You're like, oh, I could kind of make some estimates for how much that would bend. I can make some estimates for the moments that are on the ends, right? You guys have taken statics, so you're familiar with this, right? You kind of begin to see the world in a different way. So you're like, oh, well, that's a pressure vessel where I'm storing oxygen, liquid oxygen, or liquid hydrogen for aerospace, right? And how much pressure can it take? How thick do I have to make the walls? Those types of things, we may not have explicit problems, that would be a room for improvement, but to be more relevant to aerospace engineering, but that's the type of thing that we'll develop in this course. Okay, that type of intuition. Good. Anything else? All right. Good. All right, so at this point, I will kind of close my mouth. All right, and I'll let you guys kind of start working on the problems, and I'll be going around if you have questions. If you came in a couple minutes afterward, if you have preferences for, send me. Oh, that's another thing I should say. Yes, you can use my email address, okay? But I would strongly prefer that you use Canvas for official contact, okay? Because what happens is then I can log into Canvas and I see your emails and I can address them easily that way. Those of you who have sent me emails in the past know that I can go into some type of okay, so that I'm not the best at emails. There's also the GroupMe, which I highly suggest that you subscribe to, all right? Let me see if people have done that already. But that is another way to kind of hopefully get a fast response. If it's a grade-related question, you're welcome to ping me and GroupMe, but it needs to come through email because as we all know, GroupMe, oh, awesome, a lot of you have joined it. It just didn't give me, okay. As you know, with GroupMe, you can delete whatever you want, okay? So that's not like a real great official way to communicate. All right, but it's a good way to talk about technical content. My ask for the GroupMe is that the questions be a little bit specific. Say, instead of saying, has anyone got number 4? All right? Like, how do you do number 4, right? Like, here's a screenshot of my work. What am I doing wrong? That's perfectly fine, right? And it's okay if someone else is like, well, this is what you have to do, and they send a screenshot of their work. That's perfectly fine, right? For the homeworks, I'm completely fine with it. That's collaboration, in my opinion. Other people might feel that's whatever, something else, right? But I think that's perfectly fine. Of course, during the exams, that's not permissible, okay? But for the homeworks, that's fine. Okay, you had a question?
Do you mean like the discussions tab in Canvas to
No.
message you?
That we can experiment with it, but I don't use it.
What do you mean then through Canvas?
Oh, I mean, so in Canvas, you can message the instructor.
Oh, you just click
Yeah.
on.
Yeah, you can send me a message, and then it goes into. There's like you'll have an inbox, and I'll have an inbox, and it goes to my email as well. So I'll see it in my email, and I'll see it in Canvas, and that way I can. And then I have like a separate, like. Yeah, and then you have an official. Then we can go back and forth that way. Just be careful. The attachments can be a little bit funky when you start doing stuff in Canvas. So like it is often easier to send a screenshot through email. But if it's a screenshot of like technical content, okay, yeah. But you can still send attachments through Canvas. Okay. Thank you. Thank you for asking, Owen. All right, go ahead. Feel free to work together, and we'll leave this on. And if you have questions, then I'll just go ahead and I will keep this. I'll keep them both here. So if people have questions, we can go to the board, which is right here, or we can go to the notes, all right, which are right there. Okay. And I'm going to mute for a second because I need to talk with you, Julio, right? Let me just mute this so that we can get you squared away. So the question, so the website is, this is the website that you'll be able to use for finding information, okay? And
Scroll down one slide.
or it's here, like, just to go through it. If you go to this mechanics materials, then you have, we're in session 1 today. Okay. And this is being recorded as well, and it's on YouTube, and it'll be, I mean, if you feel like you missed anything when you came in, you can just watch it. You can watch it now if you wanted, but it'll go through kind of some of the logistics for the course. And then down here in the instructional, this one, okay, these are the slides. Okay. And these were worth 0 points, but now we get to where things are actually worth points. And you can watch the YouTube video to get to this. And you're welcome to use decimals if you like. Some people like that for doing your calculations. Using Colab is fine. I can't prescribe decimals, okay, because you're supposed to go through them, but I know people like decimals. I'll just leave it at that. But also Colab and your calculator are fine, especially for a lot of this. Okay, so we do have some outlets. That's good. People need them. There's one over there. People need access in the future. It's going really well.
McMath?
Yeah, McMath. Thank you so much for your comment. Actually, can I single you out for a second?
Sure.
Okay, so I've been told by a person that it can be very helpful to go back to the videos sometimes and just go back and forth if there's something that we covered too quickly or whatever to kind of understand things, and this can help enhance clarity. Just somebody told me this. That's all.
It's good seeing you, Professor.
Good seeing you.
Whenever you actually yeah.
I have an idea where this is called this is alright. So actually, I was so.
Oh, and I'm sorry to bother you one more time. Okay, so here's the late policy, okay, just so we're clear. I should have made this clear earlier. The late policy, which you can see on the syllabus, is Canvas will automatically take off 25% per day late, okay? So get everything in by 10:30 a.m. tomorrow morning, because 10:31 it will do it. Yes, if you have extenuating circumstances, let me know. If you're going to be absent, there's the Dean of Students. You can contact them. That information's in the syllabus. Also, the if we need to have circumstances, accommodations, please send me the letters as soon as possible, okay? And we'll make those appropriate arrangements with ODS. That's also in the syllabus, and that's also according to records policy. Okay, thank you. Oh yeah, that's the other thing. You've now seen, you get infinite attempts, for better or worse. All right? There's no penalty for that. You guys have questions? No. You okay? What's the question?
Do you have a check? Type C?
Oh, what? Type C.
Yeah. It's like a regular iPod check.
Oh, I don't have an iPod.
Oh, it doesn't matter. It's a Type C. Do you know?
USB C. I think actually the short answer is no. I have a lot of things here, but I think I do not have that.
Oh, wait. I got mine.
You got yours?
Yep. I didn't even know.
Okay. Well, if you want a USB port, I have that you can plug
That would
into.
be amazing.
That would. Okay, but this is an old standard USB.
Yeah, it doesn't matter.
Okay, you can come up. Yeah, that will work. Yeah, that I have. Yes.
How does rounding work? Like how many decimals?
Good.
How exactly?
Good. So the solutions for the formulas, it's either usually 3% or 5% that you need. Okay. I mean, and sometimes that's a little bit generous. Like with some of these, it's really you'll see, like, especially when we do, static inventory problems, tomorrow, we'll do that tomorrow. Yeah, you'll see that it's really just an exact figure, but yeah.
Okay, that's fine.
Don't go bonkers with the significant figures, okay? Don't worry about that too much, like, I try to be reasonable, so like, normally I'm not, very rarely do you need to go over 2 decimal places, okay? But you'll see in this session, right, there's a lot of business about units, right? And making sure, we're trying to be specific about which units you use.
Okay.
Yeah. Good questions. I'm much more confident in the answers that on these questions than I was last semester. So these questions have been kind of now, I mean, I can always make mistakes, but they've been kind of vetted by a bunch of people. But so just let me know, sometimes I make mistakes, right? And I'm happy to fix it or do what I can. Yes, Jason.
It's not something specific about this, but do you know what like Rutgers facilities are like open over the summer?
Yeah, so a little bit. I mean, Wordland, which is our closest one, right? They are now back open, I think, starting at 8 a.m. to evening. They were closed for a little bit, or they had limited hours.
What about like places to like do work, like libraries and like student centers?
Yeah.
They're all
those. Yeah, and we'll see. I'm happy to. I don't know if there's a class in here afterwards, right? But like I could see people wanting to continue working here. So we'll find out today probably. I mean, I have something. I'm gonna leave at 12:25. But. Yeah, so the group meeting, I mean, you guys, and then you have your teams that you can, your groups that you can, so I hope that you can work together, balance. Yeah, and I'm a big fan of dimensional analysis, all right? So it's easy right now, but do it in the very deliberate way, right? Where you have meters, newtons, kilograms, right? So you're keeping them all straight and you're crossing them off as you do things, okay? The organic chemistry tutor, that's one of the videos on session 1. If you're not familiar with that, that person goes through it pretty quickly. And that's a linked video to session 1.
So one over. Well, the ratio. So convert over to yeah.
Okay. Yeah. Good. Okay, so.
Increases the moment, so we'll get to that, but if B would support less, right, so it was one over, I mean, being wider, it increases with B, right? So that scales linear, right? If I increase H, it goes with H squared. Okay, so this approach, right, it tells you what the initial, right? Thicknesses, initial,
Is this the thickness or is this the thickness?
so H is the thickness in this direction, okay, and this is the width. So this is good, so we'll,
I'll go right here to kind of give an idea, right? So there's a question about how to approach these scaling relationships, okay? So this is a okay, and so what you might see is, okay, you can support maybe an Fi, okay? And my goal is I have to multiply by some factor to figure out what the F nu might be, okay? Right, so this is, if we're talking about forces, it could be a torque, right? It could be Ti times some factor equal to T nu, right? It could be a Ti times some factor is equal to T nu, right? So the question is, how do we get from Ti to T nu? So in the case of the axial loading on a bar, right? I have some initial Fi, and then I got to figure out what that factor is to get to the F nu, right? And if I have, this is axial loading on a bar, okay, on a bar. Okay, so in this case, right, I know that it scales with area. Okay, well, that's what I've told you. We'll go into detail on why that is as we go through the course, right? But if I increase the area, right, then I expect that I can, like, if I increase the area, I can expect to hold more, or I can support more force, right? So what you could say is, if I increase the area nu, and I have my area initial, right, that would be the factor there. Now there are some questions. What happens when you've got multiple factors, right? That's the question. So if you have multiple dimensions, or you could call factors, right? So in that case, let's say that I have something where there are multiple factors. I know, for example, that if I make it thicker, okay, it's going to go with a square. So then that means that I have h new squared over h I squared. If I make it wider, I have b new over the b initial. Okay? And if I make it longer or shorter, right, that's inversely proportional, right? So if that's the case, then I have Li over L new, or I could have 1 over L new divided by 1 over Li, right? And this will be the new force that I can support. Okay, so like this right here is the equivalent of 1 over L new over 1 over L. Okay, does that make sense?
I just messed up. I didn't convert the units.
Oh, right. Yeah. I get you on that. I'll get you on that. Yes. The newtons, right? 4.45
Yeah.
newtons per pound.
So I was like, I did that, but I didn't get it wrong. And I was like, oh, very well.
Yeah. And there's some foot pounds in there too, right?
Yeah.
Just a thing on units, okay? Since we're, this just a note on units. I really like that today many units are simple to keep track of if you just use the web browser. Okay, so if you guys, so like if I want units of pressure, right, all I have to do is like if I say, oh, that's the wrong keyboard, whoops, here, right? 1,000 newtons divided by 1 meters squared, right? So that should give us 1 kilopascal, right? Or 1,000 pascals. So, well, this is not a good example because that is being. Yeah, so if you use Google, for example, it'll do it for you. Right, so you can just put in 1,000 newtons divided by 1 meter squared or something like that, right? So, or if you have more complicated things, right? Like, even things like, I have a mass of 1 kilogram and I'm accelerating it at 1 meter per second squared, okay? Tells you it's 1 newton. Okay, can you do this on the exam? No. All right, but is it useful for checking things? Yes. Do you have a question, Kayla?
Could you just draw a picture for what's going on in question 9?
Okay, so question 9. That's 10. Okay. This is great. Good. Okay, so here we have, and what I'll do here. Sorry. Okay, try to make it a little bit bigger. So we have an electric motor running at 10 volts and 54 amps. So motor, 10 volts, 54 amps. Okay, and so we can draw some type of motor, and it has a shaft. Okay, and it's lifting. A mass, so this is the motor. Here we go. Okay, so this is the motor. Oh, you gotta be kidding me. This is a shaft, and this has a diameter of 3 centimeters. Okay, and it's lifting a mass of 5, so M is equal to 5 kilograms. Okay, and there's gravity acting on this, right? So there's gravity. Sorry, I reinstalled my Windows operating system, and so all my presets, a lot of my presets are not quite set up. Okay, so there are kind of a couple ways to think about this problem, all right? One is the more complicated way, and one is the simpler way, all right? The simple way, all right, which kind of circumvents the shaft diameter, is to think about power and power equating power, okay? So we have electrical power, all right, and that is given by current times voltage, okay? And so we can calculate that out as being 10 volts and 54 amps. In this particular case, okay, your numbers may vary a little bit. And you have mechanical power. Okay. Force times velocity, okay, or a small v. Okay. So the question is asking, how fast is this mass rising? Well, here we have a mass of 5 kilograms acting under gravity, right? And we have some velocity that we don't know how to solve for. And we know that and we're assuming here that we have 100% conversion. Is this a bad assumption? Can be, yes. Is it a pretty good assumption though for electrical motor? Actually, yeah, not so bad. Okay, so what we can do here is we can say that P is equal to PM, and in this case we have IV is equal to F little v, and we can say that little v is equal to F, IV over F. Okay. That's the fast way to do it. Another way to do it is to kind of go through a few different steps. Still calculate the PE, the electrical power, right? But you can say that mechanical power can also be given as torque, okay, times omega, right? That's another way to look at this. And so what's the torque? The torque is going to be the 0.03 meters, right? It's, well, maybe I should write it, it's RF, right? It's R times F. So that's R, okay, I'll just do it this way. That's R times F, and then this is 5 kilograms times 9.8 meters per second squared, okay? So we could, if you want, right, you can figure out what the torque is, sorry, you already know what the torque is. You can figure out what omega is, okay, from here. So we could, the other way to do it is to figure out that omega is equal to IV over torque, okay, and that, so omega is in radians per second, okay, and so velocity is equal to radius times omega. So the radius comes back in here, and I can say that it's 0.03 meters times whatever the omega is that you calculated, right? Because this PM is still equal to PE. All right, so that's the longer way to do it. Does that make sense? Okay, so that we can solve again. Yeah, I mean that's pretty much, those are the two approaches.
Thank you.
All these notes, again, they're accessible on the website now. If you just click on that link at the bottom, it should populate. All right. Well, I guess I went a little bit late. Thank you, everybody, for coming and for participating. And I will see you tomorrow.